Hello, Math 153. This is 11.4 Fundamentals of Probability. What we're looking at with 11.4 is going to be two different kinds of probability. We're going to be computing theoretical and empirical. We're first going to start with theoretical. This is when you would conduct, say, an experiment, like tossing a coin. And we know when we toss a coin, we get two different possibilities here. You can either flip a heads up or it could land tails up. Those are the only two ways that this could be the outcome, if you will. Heads and tails makes up what we call the sample space. Sample space is denoted with a capital S. So we could say the sample space of this experiment would be either the coin landing heads up or the coin landing tails up. That would be the sample space. So the sample space is the possible outcomes. The event is denoted with a capital E. And we could say the event of the experiment with the coin landing, we'll say heads up. So again, what we would say here is this would be the event of a coin landing heads up. And that's what we're going to be looking at. So to compute the theoretical probability, we can set up a kind of like a form, if you will, here. And this does come out of your textbook as well. You can read through that on your own, but we want to say the probability of any certain event E. Now, this event E could be flipping heads up, tails up, or whatever it may be with the experiment that we're looking at. And the way we want to compute this probability is we want to find out the number of outcomes in event E. And we're going to divide that by the total number of possible outcomes. So this is going to look like the number of our event divided by the number in the sample space. So using this idea here, we want to use this formula to compute the probability of a coin landing tails up. So just to kind of run through this, we know that the sample space of this event is going to be heads and tails. Those are the two possibilities. Now we want to find the event of the coin landing tails up. Well, we know there is only one number of outcomes that we are looking for, whereas the sample space has two. So therefore, if we are using this formula, the number of the events divided by the number in the sample space, this would just be a 1 out of 2, because there is one specific thing we're looking for the event, and we are dividing it by the number in the sample space. We are going to always leave these answers as reduced fractions unless the directions specify otherwise. But we always want to make sure we reduce them. The next example we're looking at is going to be computing the theoretical probability again, but now we're going to be going off of a die that's rolled. And we want to think of this as a normal die. A normal die has 6 sides. So we're going to say a normal die has 6 sides. And just to kind of familiarize ourselves with the die, they have dots on them, 1, 2, 3, 4, and 5, 6. So therefore our sample space here is going to be a 1, 2, 3, 4, 5, and a 6. Those are all the different possible things that we could roll with the die. So the first one we're looking at here is we want to find the probability of rolling a 3. Well, out of this list, there is only 1 3 out of 6 total possibilities. So this would be 1 out of 6. Again, the number in the numerator is how many of these would satisfy what it's asking. The denominator is always going to be 6 in this case because there's 6 total possibilities. So now we're looking at an even number. So looking at our sample space, we know that a 2 is even, a 4 is even, and a 6 is even. So here, there's 3 different possibilities out of total of 6. We want to always reduce our fractions, so we get 1/2. You have 1 out of 2 chances of rolling an even number. Now a number less than 5, you could roll a 1, 2, 3, 4, but we can't roll a 5 because 5 is not less. Well, we see we have 4 total in the event that we're looking for out of 6 total, which would simplify to 2 out of 3. A number less than 10. Well, when we look at this setup here, we notice all of them are less than 10. So 1, 2, 3, 4, 5, 6. So that means that you might get a number less than 10 out of 6 total, which would be just simplified to 1. That's 100% probability that you would roll a number less than 10. Kind of opposite that, a number greater than 6. There isn't any. So that would be a 0 out of 6, which would just be 0. There's a 0% chance of rolling that. Moving forward, done the same thing back over here. We could have wrote out, for example, we could have wrote out even over total. There's 3 evens at a total of 6. I just skipped that step because these ones were pretty strong. The next one we have, we're looking at a deck of cards. Like I mentioned in class before break, you want to make sure you're very familiar with a deck of cards. I believe in your textbook it's on page 718. You can always go to the e-text contents in your Pearson site and type in page 718 and it should pull you up to this. If not, you can always Google deck of cards and read about it, but you want to make sure you're familiar with it. So now we're going to be doing the same idea but talking about a deck of cards. So the first one, you're dealt 1 card from a standard 52 card deck. So 52 cards is how many a standard deck has. We want to find the probability of being dealt a king. Well, we know that the standard deck has 52, so that is going to be our sample space. Instead of listing them all out, we know that our sample space will have 52 in it. But what we want to do is look at kings. So you can see from this picture that there are 4 different kings. So this would be, we want to find the number of kings over the total amount. Well, we know that there are 4 kings out of 52 total. Simplify that to 1 out of 13. The next one, a heart. So we want to take the number of hearts in a deck, divide it by the total. Well, hearts, so now what we want to do is look at all of these cards here. And if you're not familiar, there are 13 of each different suit here. So 13 out of 52, which would simplify to 1/4. The lastly, King of Hearts. Well, there is only 1 King of Hearts here. So now we want to find the King of Hearts out of the total, which would be 1 out of 52. That doesn't simplify. Now you could use the same approach. You can see that I wrote these out here in words. I highly recommend doing that for all of your problems. You could forward, but I would highly recommend doing all of this for your problems. The next one we're going to be looking at is the probabilities in genetics. So I'll give you a moment to go ahead and read through. I'm going to pause my video and I recommend you pausing it on your end to read through this paragraph here and then take a look at the chart. Okay, after reading through it, you will see that the question is asking us what is the probability that the child will have cystic fibrosis? And we see that this chart has 4 different notations to it. And on the right-hand side in this little blurb right here, it goes through what each of them mean. It does tell us that CC, so 2 lowercase c's, is a person sick with the disease. So we want to find the probability of having the cystic fibrosis, which means we want to find the 2 lowercase c's. So we want to find the probability of having the cystic fibrosis over the total possible options. Well, we're looking about that. So the lowercase c's, which would be there's 1 of them at a total of 4. Okay, now let's go to our last example. And what we're looking at here is empirical probability. So this is the other kind. Empirical probability is going to be once a survey has been conducted, and then we just want to kind of analyze the data and say, okay, well, here's the probability. More currently, you could think of this pandemic going on now with the coronavirus. We can look at the data that's out there and say, okay, here's the probability that you could get the coronavirus. So we're not necessarily conducting an experiment like picking a card or flipping a coin, but yet we want to look at the data that has been done. So what we want to do here to calculate the empirical probability, we want to find, so the probability of a certain event, just like we did before, is now instead of talking about the number of options that we're looking at, we want to look at the observed number of times the event has occurred already, because that's what the difference is. The theoretical is a theory, an experiment. This one is empirical. We're looking at what has occurred over the total number of observed, that says observed occurrences. So the last example that we're looking at, it says in 2010, there were approximately 242 million Americans ages 15 or older. This table here shows the distribution of marital status, gender of the population. So the first thing we're looking at is we want to look at if one person is randomly selected, find the probability to the nearest hundred. So that tells us we need to use a calculator here, that the person is divorced and then is female. So what we want to do is start with the number of divorced. You can see that there are 24 divorced people, male and female, and then we want to go out of the total amount. And you can see that this chart has all the totals. This 242 represents the total number. So we want to find the probability of someone being divorced. So we want to take the number of divorced people and divide it by the total, which would be 24 out of 242, because we have 24 divorced, 242 total. And then since we have to round this nearest hundreds, you want to divide to find it's approximately 0.1, and then with proper rounding, it would be 0.10, because I believe you get 0.09917 and so forth. This would be the kind of answer you'd have to use in the Pearson site and watch your rounding, because it will deduct points if you don't round correctly. So now I'd recommend pausing your video here and then working through the probability of choosing someone that is female. So go ahead and pause your video. Okay, now let's look at and check, see how you did. So the probability of someone being female. So now here's the female. We need to go to the end of this and see that there are 124 total females that were surveyed, again, out of the grand total of 242. Actually, let me actually go back a step here and write out in words what we're looking at, just so we keep it consistent. So we want to find the number of female over the total amount, which would be 124 out of the 242. Use your calculator, divide to the nearest hundredth. After rounding, you'd get 0.51 would be your final answer. Now with this, that should give you enough to get through the homework. If you have additional questions, please reach out. Use the options available to you in Pearson for help. We can always do a Zoom session if you need help. Just all you have to do is communicate with me and ask where the help is needed. Have a great day, and I hope this video was helpful.